Good afternoon, everyone. Let us start. Remember, we have been learning geomorphic processes, Chapter 6 of your NCERT textbook, Fundamentals of Physical Geography. Last time we discussed about different types of geomorphic processes, and now we shall discuss about endogenic geomorphic processes in detail. Now I will present my screen. Here, endogenic processes. Let us read. About the meaning of endogenic processes, we have learned earlier the forces coming out from the earth interior, okay, are acting inside the earth surface, and those processes are known as endogenic processes. So let us read. The energy emanating from within the crust of the earth is the main force behind endogenic geomorphic processes. So for the endogenic processes, okay, like diastrophism and volcanism, the main force behind these endogenic geomorphic processes are coming from the earth's interior, okay, and this energy, that is energy emanating coming from the from within the earth, okay, is mostly generated by this radioactivity, then rotational and tidal friction, and primordial heat from the origin of the earth. Okay, see here, the forces coming from the earth interior are mostly generated by radioactivity, then rotational and tidal friction, then primordial heat from the origin of the earth. Okay, see here, radioactivity. So radioactivity is related with the these convection currents, okay, generated within the mantle. See here, we have to call back this diagram, and here we also have already discussed, okay. See here, this is the crust, and here we have this mantle, okay, and within the mantle these convection currents are generated because of radioactivity. Let us suppose here some radioactive elements, uranium, thorium, are present, and when these radioactive elements are decayed, heat is released, okay, a great amount of heat is released, and because of that the rocks are melted, and the melted rocks are forced to rise upwards, okay, just see the arrow, forced to rise upwards. Then as soon as it reaches the base of the crust, so it is bifurcated in this way, just see the arrow, okay, and it is going here like this, and again going back just below the other this continental plate. And see here, when the movement of the this magma, okay, when the magma are cooled down, then again it is sunk downwards, and again it may reach the source area. So in this way we have this circular movement, okay, of this magma inside the mantle, and what we call convection currents. And because of this movement of the magma below the crust, here the plates are moving, Okay, this one we have discussed earlier. See, slab pool. That means because of the movement of the magma, this section of the crust known as plate is pulling towards this side. Okay, so what I want to say is that these endogenic forces, means forces coming from the earth interior, are mainly derived from this radioactivity, and radioactivity is related with the convection current. Okay, then another one is rotational and tidal friction. So it is related with the rotation of the earth. Let us see another diagram. Okay, see here. Here the earth, okay, this is the earth, and we know that earth is rotating. See here, see the earth is rotating, okay, from west to the east on its own axis, and because of this rotation of the earth on its own axis, okay, objects on the earth's surface have a tendency to move away, okay, to fly away, to throw away from the surface of the earth, and that is what we call centrifugal force. And because of this centrifugal force, okay, and the gravity of the moon, the gravitation pull of the moon and the sun, okay, see some of the objects or these ocean currents, okay, or these ocean waters, then atmosphere, and according to Alfred Wegener, even these continents were moved away, okay, from a particular point because of this force, that is rotational force, what we call centrifugal force, and this tidal friction, that is the gravitational pull of the moon and the sun. Okay, however, see, this rotational and tidal friction, actually the force is not strong enough to move away the plates, okay, from one place, as suggested by Wegener. However, this rotational and tidal friction is very important for the movement of the these ocean waters, rising and falling ocean waters. Okay, and another one is the primordial heat, that is the heat retained, okay, that when the earth was formed. So here we have one more this diagram. Okay, see, let us suppose this is the primordial earth, that is the early earth. Okay, so we know that the earth was formed after cooling down a very hot gaseous matter. We have so many theories, okay, nebular hypothesis, then other this accretion, then planetesimal hypothesis. So many theories are there, but one of the hypotheses tell us that the earth has been formed after cooling a hot gaseous lump, and let us say this is the primordial earth. Okay, and see, after cooling this hot gaseous lump, and through the process of accretion, okay, see here the small objects are pulling towards the earth. Okay, through the accumulation of these materials, the earth has been formed, and this heat, okay, this heat has been retained in the earth interior, even though the outer surface of the earth has been cooled down and it becomes a solid body, and but inside the earth that heat is retained. Okay, the heat generated at the time of origin of the earth has been retained inside the earth interior, and that heat is known as residual heat. Okay, and because of this heat, sometimes it is said that convection currents are generated. Any question from your side? Any question from your side?
Sir, centrifugal
Centrifugal force. Okay.
Yes, sir.
Okay, centrifugal force, you know, Earth is rotating on its own axis. Okay, and because of this rotation of the Earth on its own axis, any object on the Earth's surface have a tendency to move away. Just like see, you can take an experiment also. Just take a rope and at the end just bind one stone and just turn, okay, this string or rope around your hand, and that stone will pull your hand, and that force is known as centrifugal force. And the same force is also present when the Earth rotates on its own axis. And according to Wagner, because of this centrifugal force, the continents were broken, okay, from the Pangea, from the supercontinent, and moved away in the different directions. And one more thing is that because of the gravitational pull of the this moon and the sun, okay, these objects, according to Wagner, even the continents, okay, were also moving away from a particular point because of the gravity of the moon and the sun. Okay, any other question?
No, sir. No,
okay,
sir.
then let us proceed. Here the energy, this energy, let us continue. This energy due to geothermal gradients and heat flow from within induces diastrophism and volcanism in the lithosphere. The heat, okay, the energy derived from this geothermal gradient. Geothermal gradient means this here. Geothermal gradient means increase in temperature with increase in depth. When you get down into the Earth interior, then temperature is increased. Generally, the rate of increase is 1 degree Celsius for every 30.4 meter. If you get down in the Earth interior by 30.4 meter, then temperature will be increased by 1 degree Celsius, and that is what we call geothermal gradients. Okay, that the rate of change of temperature with increasing depth. And this energy derived from the geothermal gradients and heat flow, that is the convection currents within the mantle, okay, induces, that means causes diastrophism and volcanism, the two types of endogenic geomorphic processes. So what are diastrophism and volcanism, we are going to learn. Okay, here about geothermal gradient. So let me show you one diagram here. See, actually this is these are charts, okay, graphs representing geothermal gradient, and here this diagram, this graph shows a normal situation, normal thermal gradient here for this particular place. And if you see this red graph, okay, red line, see, this is the geothermal line. So it means that say the rate of increase in temperature is gradual. Okay, the rate of increase in temperature with increasing depth is gradual here in this case. And then after this 100 kilometers below the surface, again the rate of increase in temperature is constant, almost steady, constant. Okay, this is for the normal situation. But at the mid-oceanic ridge, see here, at the mid-oceanic ridge, here this is the geothermal gradient line, the graph, and it shows that here the rate, just see the line, okay, here the rate of increase in temperature with with depth is very high. The rate of increase in temperature with increasing with increasing depth is very high. See here, this is 50 kilometers, the depth is 50 kilometers, So at the mid-oceanic ridge, within 20 kilometers from the sea floor, temperature, okay, see here, is more than 1000 degrees Celsius. That means the rate of increase in temperature with depth is very, very high. Okay, so within 20 kilometers the rate of increase is very high. Because of that, say within 10 kilometers the temperature is more than 1000 degrees Celsius. And after that, okay, then beyond this 20 or 10 kilometers, then the temperature is again constant. So in this way we can read, okay, the others also. So this is about the geothermal gradients, okay. And due to variations in the geothermal gradients and heat flow within from within, that is convection currents, crustal thickness and the strength, then the action of endogenic forces are not uniform, and hence tectonically controlled original crustal surface is uneven. That means last time we discussed a question that why is the surface of the earth uneven, why is the surface of the earth is not smooth, and again this line tells the answer for the original crustal surface. And last time also we discussed that because of the this differential movement, okay, of the crustal rocks, we have these different landforms, major landforms on the earth surface. And here also it is mentioned that due to the heat flow and the geothermal gradient, and due to the differences in the thickness of the crust, and due to the differences in the strength, okay, or the hardness of the crust, and at the same time the endogenic forces are also not the same. In some places the force of these endogenic are very strong, and in other areas endogenic forces are not strong, and that is why we have development of landforms in different parts of the earth surface. Okay. Any question from your side? If you don't have, then let me proceed. Here, as I told you, we have two types of endogenic processes, that is diastrophism, and another one is volcanism. Okay, let us read diastrophism. So what do you mean by diastrophism is given here. All the processes that move, elevate or build up portions of the earth crust come under diastrophism. All the processes, all kinds of movement, okay, that elevate a part of land surface or that move from one place to another place is known as diastrophism. Here the movement may be in any direction, okay, as we discussed earlier. The movement may be this upward, or the movement may be downward, or maybe horizontal like this. Okay, so all these types of movement, okay, on the crust of the earth is coming under the term diastrophism. And diastrophism, these include number one, orogenic processes. Okay, so orogenic processes involves these mountain building through severe folding and affecting long and narrow belts of the earth crust. So we have four types of diastrophism: orogenic processes, epizonic processes, and earthquakes, and plate tectonics. So these are the four main diastrophism, okay, main types of diastrophism. And the first one is the orogenic, and the orogenic processes are those processes, okay, involving mountain building through severe folding and affecting long and narrow belts of the earth crust. So here the word orogenic is derived from the word oros means a mountain. Here again we have to call back this diagram. So this is about orogeny, okay, orogenic forces. In this case, here two forces will be coming together, okay, towards common point. This is what I call compressional forces, and this is under the term endogenic processes. And because of these compressional forces, see here, crustal portion of the earth has been folded in this way. Just see here, it is folded, okay. So that is the point mentioned here. And if the folding is okay, if the folding is horizontal, then sometimes there may be sliding here. So in this case, okay, there is sliding, faulting also may be here. So this is a fault plane, okay. So this is about these orogenic processes, okay. So orogenic processes involve mountain building movement. So this is mountain building movement, this horizontal movement, okay, two forces coming together towards the common point. This is mountain building movement, and because of this movement, these mountains, okay, have been formed. And next we have these epirogenic processes, okay. Epiros means continents, okay, continents. And epirogenic processes involving uplift or warping of a large part of the crust. So epirogenic movements involve uplift, means upward or downward movement of large part of the crust, okay. Just see here, this one. So this one is related with the epirogenic movement, okay. See, vertical movement is there because of the upward or downward movement, okay. This portion has been subsided, okay. This is called a faulting process, which you have learned earlier, thus forming a rib valley. Sometime a large part of the earth crust may be uplifted, okay, thus forming a continent. And here this is a plateau known as horse, okay, and this is graben or rib valley. So all these upward or downward movements, okay, are known as epirogenic movement, because this type of movement lead to the formation of these continents, okay. Epirogenic movement means continent building movements, that is involving uplift and warping of large part of the crust, okay. This one, do not forget this one. So this is epirogenic, okay. Then earthquakes, about the these causes of earthquakes, effects of earthquake distribution, we have already learned. So earthquakes are coming under the term diastrophism. So earthquakes involving local relatively minor movements. So because of earthquakes, there may be deformation on the earth surface, or deformation is related with the earthquakes, okay. That means simultaneous. Earthquakes and deformation are these simultaneous. See this diagram. So an earthquake has occurred here inside the crust. So waves are propagated, and because of this, there may be the sliding of the rocks here, okay. See here, one is going to this side, another towards this side. And because of the earthquakes, there may be the sliding of the rock, faulting process, or because of the faulting process, there may be earthquakes, okay. When the two rock masses are sliding towards each other because of the stress, okay, earthquake may occur. Then the last one is plate tectonics, okay. So plate tectonics involving horizontal movement of the crustal plate, and theory of plate tectonics also we have learned earlier. So plate tectonics involve the horizontal movement of the crustal plates. So just let us recall one diagram, okay. So here this diagram shows the movement of the plates, and just here, because of the convection current, this plate is moving towards this side and pushing beneath the continental crust. Okay, this is what we call subduction zone. And here also this plate is moving towards this side, pushing beneath the continental crust. Okay. So this is about plate tectonics. Any question from your side? Boys and girls?
Sir, repeat amuka toro diagram to janta je.
Okay. See, according to theory of plate tectonics, okay, the Earth's crust is composed of 7 major plates and some minor plates, and all these plates, that is a plate, you know, is a large part of the crust. Okay, and all these plates are moving in different directions because of this magma flow. Okay, see here. We have learned that within the mantle, magma are moving, what we call convection current. And because of this convection current, okay, these plates composing the crust is moving in different direction, and this is what we call plate tectonics. Okay, in this case, see, this oceanic crust is pushing beneath the continental crust. So this is continental crust, and one plate is pushing beneath the continental crust, and because of this the mountain ranges are formed here. Okay, here the mountains are formed because this oceanic crust is pushing beneath the continental crust, and likewise here also. And here along the mid-oceanic ridge, here we have volcanic eruption. Okay. So this is about the diagram, and actually we have also already learned. And here one more concept related with the plate tectonics is that here this is a plate boundary. Okay, the meeting plates between the two plates. Here this is the continental plate and this is oceanic plate, and these two plates are coming towards a common point. And here this plate boundary, see here. Here this plate boundary is known as convergent plate boundary. Okay, and here along this mid-oceanic ridge, this is known as divergent boundary because two plates are moving away. Two oceanic plates are moving away. Just see the arrow. Okay, so this is what we call this plate tectonics. Okay, the last one, so plate tectonics involving horizontal movement of the crustal plates. Remember, the crust of the earth is composed of 7 major plates and some minor plates, and these plates are moving in different directions because of the convective flow inside the mantle. And because of this movement of the plates, mountains, okay, including Himalayas, have been formed, and some other major landforms, rift valleys, have been formed. So, and this term plate tectonics is coming under diastrophism. Okay, a type of diastrophism. Let us proceed. So, in the process of orogeny, the crust is severely deformed into fault. Okay, that we have seen that diagram also. This diagram. So, because of this orogeny movement, this crustal portion has been deformed greatly. Okay. Into folds, and due to epirogeny, that is the vertical movement, Okay, there may be simple deformation like this faulting process. Then orogeny is a mountain building process, whereas epirogeny is a continent building process that we have told you earlier. And through the process of orogeny, epirogeny, earthquakes, and plate tectonics, there can be faulting and fracturing of the crust. So because of all these diastrophism processes like orogeny, epirogeny, earthquakes, and the plate tectonics, there can be deformation on the earth surface. There may be fracture or there may be faulting, okay, on the earth surface. I think fracture, faulting, you have learned earlier. This is what we call what? So this is called faulting, and fracture means, see here, it is mainly found at the mid-oceanic regions. Okay, so there may be fracture here in a particular place. And next we have this volcanism, and here the meaning of volcanism is given here. Okay, volcanism include the movement of molten rock, that is magma, onto or towards the earth surface, and also formation of many intrusive, extrusive volcanic forms. Okay, in chapter 3 this we have learned. So volcanism means movement of magma inside the earth interior. Okay, here it is very simple. Volcanism means, see here, this is the crust, and here we have a magma chamber, and this magma may rise upward, and here cooling may take place, or it may rise above the earth surface, and it may cool down here on the surface after eruption. Okay, so all these activities are collectively known as volcanism. Okay, volcanism include movement of molten magma on the earth surface or inside the earth surface, forming different landforms. If different forms are made inside the crust, we call it intrusive forms, and if different landforms are made on the surface of the earth, these are known as volcanic forms, landforms. This we have discussed earlier. Okay, remember the different types of volcanic landforms like caldera, okay, then flood province, then different others types of volcanoes. Okay, and for the intrusive, those Pakoli, Lakoli, Sil, Dike, you have to call back all those terms. So we shall not discuss about volcanism in detail because we have already learned earlier. It is also mentioned here, already been dealt in detail under the volcanoes in unit 2. Okay. So any question from your side?
No, sir.
Okay, then let us stop here for today. And don't forget to send your names in the WhatsApp group for attendance. Thank you very much for joining my class.